Hello everyone. Today I will be discussing some problems related to belt friction. So again I will not discuss the derivation part. So the derivation part is actually shown over here. You can just have a look. I will just directly jump into the problems. So the value comes out to be actually the formula T2 divided by T1 equal to e to the power mu s multiplied by beta. So T2 will be always larger, the greater tension. So here is our first problem over here. The problem says a hawser thrown from a ship to a pier is wrapped into two full turns. Mark the word two full turns. That means beta will be 2 into 2 pi, 4 pi. Around a bollard, the tension in the hawser is 7500 Newton by exerting a force of 1500 Newton on its free end, and a dock worker can just keep the hawser from slipping. Very good. A. Determine the coefficient of friction between the hawser and the bollard. In B, you have to determine the tension in the hawser that could be resisted by the 150 Newton force if the hawser were wrapped 3 full turns around the bollard. Now for the number A question, number A part, like we know the formula T2 divided by T1 equal to e to the power mu s into beta. Everything is given here except mu s. This is a very simple question actually. So T2 will be the larger tension, which is 7500. Then T1 is the smaller friction, which is 150. Then equal to e to the power mu s. I don't know the value of mu s, the static friction, but I know the value of beta. Two turns were made, so it will be 2 into 2 pi. That means 4 pi overall. So from that equation, you will get the value of mu s, which will be 0.311. So now you know the value of mu s. Now for part B of the question, again the equation will be T2 divided by T, like the same equation, but now you don't know the value of T2, like you were asked the force. So it will be, now the equation will be T2 divided by T1, which is 150 equal to e to the power. Now you know the value of mu, 0.311 multiplied by 6 pi. Now 3 turns were made. Where? Yeah, 3 full turns were made. So that's why 3 into 2 pi. So now the value of T2 will be like 52.7 into 10 to the power 3 Newton. That will be your answer. A very simple one. So you can have a look the solution from the book. Look, they have solved it in the similar kind of manner. Now moving to the next question. So here a flat belt connects pulley A, which drives a machine tool, to pulley B, which is attached to a shaft of an electric motor. The coefficient of friction are mu s equal to 0.25 and mu k equal to 0.20 between both pulleys and the belt. Knowing that the maximum allowable tension in the belt is 600 pound, determine the largest torque which can be exerted by the belt on pulley A. So for pulley A, let's find the value of beta. So for pulley A, the value of beta A will be, like you can see, the angle will be this, and the second connect point, so the angle will be this. So which is nothing but 180 plus this angle 60. So beta will be 180 plus 60. So this will be what? 240. That means 4 pi by 3, right? So the beta for pulley B will be 180 minus 60 this time. You can have a look. The beta will be this and another point of contact, and this will be your beta. You can find it by subtracting 60 from 180. So 180 minus 60, So the value will be 2 pi by 3. So sleeping will occur at pulley B first. Why at pulley B first? The value of mu s remains same for both the pulleys A and B. So like the sleeping will depend only on the value of beta. So where beta is smaller, sleeping will occur first in that pulley. So beta is smaller for pulley B. So sleeping will occur in pulley B. So now we can write equation for this pulley B. So equation will be T2 minus T1 will be, we are writing equation for pulley B. Why pulley B? Because sleeping will occur first in pulley B. So mu s into beta. The value of T2, the maximum allowable tension is given 600 pound. So the value of T2 will be 600 pound divided by T1. I don't know the value of T1. I have to find it out. E to the power, then mu s. What is mu s over here? 0.2025 into beta. So beta is 2 pi by 3. So from that you can get the value of T1, which will be 355.43 Newton. So now you know the value of T1, which is like this is your T1 and this is your T2. So now for pulley B, you have to find out the largest torque which can be exerted by the belt on pulley A. So for pulley A, moment about A, like moment about A. So your equation will be MA, moment about A, plus 8 into, yeah, this distance is 8, 8 into, for T1, like T1 into distance, 8 into 3, 55.43, then minus, this will be anti-clockwise rotation and this will be plus 42, like I'm showing you again. T1 will be in that direction for pulley A, so it will exert anti-clockwise rotation, so that's why I have put plus over here. But for T2, for pulley A, it will be in that direction, so it will cause clockwise rotation, so we have to write minus over here. So minus 8 into, the distance remains same, 8 inch, which is the radius of pulley A, into 600, which is given 600 pound, equal to 0. From that you will find the value of MA, which is comes out to be 1956.56 pound inch. Remember the unit over here, pound inch. So yeah, that was the solution from the book. You can have a look over here. Okay, now the next question. A band brake is used to control the speed of a flywheel as shown. The coefficient of friction are mu s equal to 0.30. Actually the flywheel is that portion and the band brake is that portion. This is our flywheel and this is our band brake. Okay, so the coefficient of friction are mu s equal to 0.30 and mu k equal to 0.20. Determine the magnitude of the couple being applied to the flywheel, that means in this flywheel, knowing that P equal to 45. That means the value of P is given over here. I can write it down for you. The value of P is 45 Newton, and that the flywheel is rotating counterclockwise. That means the flywheel over here is rotating in that manner. So if you apply brake, some tension will be generated and it will try to, you know, uh, change the speed of the flywheel, or it can stop, or it can actually change the speed. So rotating counterclockwise at a constant speed. Okay, very good. Now have a look at the free body diagram of the uh, band brake. So this is the free body diagram of this band brake. Over here the value of P is given, and this was your point B and this is your point C. So in point B, the let's denote uh, this by T2 and this tension by T1. So the value of B, the force acting on B will be T2 in the opposite direction, because that is how tension force reacts. That is how tension force works. So T2 will be in the upward direction for point B. So in the point C, you can see over here it's a hinge. So there will be two forces, like I can assume it as Cx over here and Cy over here. So in the free body diagram, you can see that. So all the distances I have marked here. So the equation you can write for moment about point C, like moment about C. Why am I taking moment about C? Because if you take moment about C, these two forces will cancel out. I mean, you don't have to write moments, no, moments for these two forces, as these will become zero. So that is the benefit. We are, you know, mm, we are actually making these moments zero, so which will make our calculation much more easier. So the equation will be 45 into 0.480 minus T2, because anti-clockwise rotation. Sorry, yeah. This will have anti-clockwise rotation and this will have clockwise rotation. So minus T2 into 0.120 equal to 0. So the value of T2 comes out to be 180 Newton. So now you know the value of T2. Now for flywheel, you can see the FBD of flywheel. So now you can write the equation T2 divided by T1, which is 180 divided by T1 equal to e to the power. Now look at the angle over here. This is our point of contact and this is, so the angle will be this one, which is 270 degree. So the value of beta will be 3 into pi by 2 into 0.30. From this equation you can get the value of T1, which will be what, 53.78. Now the last part, you have to determine the magnitude of the couple being applied to the flywheel. So the magnitude of the couple will be like, okay, I'm erasing that part. The magnitude of couple will be, so moment about D, taking moment about D, our equation will be minus 180 into 0.360 plus 43.78 into 0.360 plus m. From that equation, the value of m's comes out to be 49.04 Newton meter. So yeah, that was it. Now moving to the next problem over here. So a flat belt is used to transmit a couple from pulley A to pulley B. The radius of each pulley is 60 meter and a force of magnitude P equal to 900 Newton is applied as shown to the axle of pulley A. Knowing that the coefficient of static friction is 0.35, determine A, the largest couple that can be transmitted, B, the corresponding maximum value of the tension in the belt. So I have drawn the free body diagram over here, FBD. You can see the free body diagram looks like this. So from this free body diagram, you can simply say T1 plus T2 will be 900. This is your equation 1. Now the other equation can be found by this formula. T2 divided by T1 will be e to the power, static friction is 0.35, so 0.35 into now the angle, look over here, the angle is that, which is our beta. So the value of beta will be 180, that means pi. So you can get another equation. So the another equation will be what, T2 T2 equal to 3.0028 T1. So this is your number one equation, this is your number two equation. Now solving that two equation, you can actually get the value of T1 and T2. So like the value of T1 will be, solving those two equation, you will get the value of T1 224.84 Newton and the value of T2 675.15 Newton. Now if you find to the value of torque, you can write the equation over here, plus torque moment about A will be equal to 0. That means M minus what 75 675.15 into 0.06 plus 224.84 into 0.06 equal to 0. From this equation you can get the value of M, which will be 27 Newton meter. Very simple. So that was it. Now the next problem, which is our last problem, I guess. Yeah. So a flat belt is used to transmit a couple from drum B to drum A. Knowing that the coefficient of static friction is 0.40 and that allowable belt tension is 450 Newton, determine the largest couple that can be exerted on drum A. Now for drum A, let's find the value of, we have over here the two free body diagram. This is for FBD of A and this is for FBD for B. Okay, so now the value of beta for A will be like over here, as you can see, this, and that angle. So this will be 180 plus 15 plus 15. That means 180 plus 30, which is 210. So the value of beta will be, beta for A will be 180 plus 30. So to make it in radian, 7 pi by 6. Now again beta for B will be, now this time the angle will be this one, which will be 180 minus 30. You can see those angles are 15, so minus 30. So 180, you can also check the free body diagrams to make that understand. Minus 30, 5 pi by 6. So as you can see, the static friction coefficient are same for both the drums or pulleys. So the slipping will depend only on beta. So beta is less for this drum B, so slipping will impede first on B. So we are writing equation for B. So the equation will be T2 by T1 equal to e to the power mu into beta. So the value of T2 is 450. Yeah, over here you can see T1 into e to the power 0.40 into what, 5 pi by 6. So from that you can get the value of T1 157.914 Newton. Now to find the moment, like moment about A, we will take summation of MA equal to 0. So equation will be MA, like I'm taking now together this time 0.12 into T1 minus T2 equal to 0. Now you know the value of T1 and T2. So MA will be, if you put the values of T1 and T2, you will get 35.1 Newton meter. So that will be your answer. So actually I have ignored all the theory parts, what is beta, what is radius of friction, and all the other stuffs, why beta is in radian. Actually these are, I mean, these are needed to be discussed in the theory part, but as I don't have enough time, so I didn't discuss that. I just directly jumped into the problems. So I hope you guys have understood it. So yeah, that was it for today. Thanks for staying with me.